Now let's have a look at an example where a compound is being electrolyzed in its solution. The ions in solution are attracted to the electrode with the opposite charge, where they are turned into atoms of the element. However, the water in the solution means that the hydrogen and hydroxide ions are always present in the water. And this may result in different substances being produced at the electrodes. The products formed depend on the reactivity of the elements concerned. The ions of the element with the lowest reactivity forms atoms first. So in a mixture containing iron and copper ions, copper is produced as it's less reactive. So let's see what happens in the electrolysis of copper sulfate solution using carbon electrodes. Notice that the copper sulfate solution has a nice blue colour. So what actually happens? You can see copper metal sticking to the cathode and the blue colour of the solution beginning to disappear. At the positive anode, bubbles of gas appear. Which gas could this be? So let's take a look at the equations for the electrolysis of copper sulfate solution. The ions present in the solution are positive copper and positive hydrogen ions and negative sulfate and negative hydroxide ions. The hydrogen and hydroxide ions are from the water. Positive copper ions and hydrogen ions are attracted to the negative cathode. Copper is below hydrogen in the reactivity series, so copper ions gain electrons and form copper atoms. Negative sulfate ions and hydroxide ions are attracted to the anode. Sulfate ions are too stable to be discharged, so it's the hydroxide ions that combine to form water and oxygen gas. It's this oxygen gas that is discharged at the anode. You can test to prove that it's oxygen by collecting the gas and placing a glowing splint into it. If it relights, the gas is oxygen. Now you try to predict the products of the electrolysis of hydrochloric acid, hydrogen chloride and sodium sulfate solution. Here is the reactivity series to help you. How did you do? Let's take a look. The electrolysis of dilute hydrochloric acid is fairly straightforward. The hydrogen gas is produced at the cathode and the chlorine gas is produced at the anode. The electrolysis of the sodium sulfate solution, however, is a little bit more complicated. Positive sodium ions and hydrogen ions migrate to the negative cathode. Because sodium is found higher up on the reactivity series than hydrogen, it's the hydrogen ions that gain electrons to form hydrogen gas. Negative sulfate ions and hydroxide ions migrate to the positive anode. Sulfate ions are too stable to be discharged, so the hydroxide ions combine with each other to form water and oxygen gas.